Uncovering student thinking in math class. I'm very excited to present this topic to you today. I'm very inspired by uncovering what my students are bringing to my class and what do I need to work on with my students. So today I want to show you a variety of tasks and probes and routines that you can use and integrate into your daily instruction that will help you become a better teacher and help educate your students with what they need to know. So again, why do I love uncovering student thinking? So my big thing in my classroom is I want to make sure I'm promoting students who become mathematicians. So I want my students discussing math. I want them using vocabulary because if they're discussing the math, I can listen in and make sense. And if it makes sense, then I know that they have understanding. I'm not just getting the head nods or the thumbs up. I'm actually listening in, and they start asking questions when they don't understand because it's been comfortable for them to talk about math. I also want them making sure they're using the vocabulary because if they're using the math vocabulary with the discussion and the probes, then I know that when they see it in a word problem, they already have memory of what that vocabulary word represents. The big thing I want to also work on is reasoning skills. A lot of times we have students that read a question, do all this wonderful math work, and then you read it as a teacher and you're like, they didn't answer the question. So the probes and the prompts and the routines help build those reasoning skills because they kind of have to verbalize it, either out loud or in written form. And they're being asked like, does this make sense? Or which one doesn't belong? Or, who is thinking like me? They actually have to build some reasoning. It also informs and drives my instruction. So my probes, my prompts, and my routines that I use are helping me determine where are the conceptions, where are the misconceptions. Do I want to address it whole group? Do I need to pull a small group? And of course, again, we want to empower the students to be mathematicians. We don't want students to think that they don't have anything to offer in our math class. And they're usually engaging because they love to talk to each other. So I want to give credit to where credit's due. I want to thank Toby, Milton, Rose, and Arlene here who created these two wonderful books that are called Uncovering Student Thinking in Mathematics. We have them from a primary all the way up to high school. Now, these are wonderful, wonderful resources. I highly suggest reading them, getting them because they really explain the ins and outs of why you create these probes. They give you lots of different examples of math probes that you can use in your classroom. And then they guide you through not only the pedagogy, but also what's another way to look at the data. Danielson and Persico do this wonderful question book, and they've created some great resources called Which One Doesn't Belong. We're going to dive in a little bit deep into that in our first example. I also want to give credit to Grace Amy here. They are, I had a wonderful opportunity to work with them, and they've created two books, Routines for Reasoning and Teaching for Thinking. So they are wonderful resources. Again, I highly suggest them being part of your math library as a teacher. Read through them because they not only give you the pedagogy and the ins and outs, but they also provide 10 to 12 different types of routines and activities you can do in your classroom to promote students to become mathematicians. And I'm only going to highlight two of those routines today. So again, our probes, our routines, our tasks are there to uncover the understandings, misunderstandings. Because if our students understand, we can then move forward to the higher level concepts and the procedures. If there are misunderstandings, that's where we have to figure out, are they overgeneralizations? Do they have a lack of knowledge of like the basic concepts, or is it a procedural issue that's going on? All together, it's informing where am I going with my instruction? Am I tackling something whole group? Am I working with students individually or in small group to improve their understanding? Again, we want to use these math tasks and probes to promote better problem-solving skills and perseverance. Many times we have students that will tell you, especially as they get older, I am not a math student, or I don't like geometry, or I don't like algebra. Because maybe they haven't had success where they've used a strategy, but maybe it's not an accepted strategy by that teacher. Or they haven't had a chance to explain what knowledge they've had coming in that they can use, and that's valid. Or maybe they haven't had somebody listen to their misconceptions and help them out. So the math tasks that you'll see at the end are basically focusing on, developing that sense of numbers in relationships, structure of the problem and repetition. So we'll look at how those pieces help our students become better mathematicians. So you might be wondering, okay, we've done a lot of talking about what these probes can do for us, but how do I create the task and probes? So we're going to start off with some basics. As always, everything we do should follow what is the standard or the learning target we're going to look at. So what is that main concept that I really want my students to learn today? So when I'm making my task, I have to decide, am I going to assess something that's grade level? Maybe I'm making a probe that builds off of something we did yesterday or the day before. Or am I going to assess something that they should be coming into class with from a previous grade? So you have to think about, what is the goal of your task and probe? Is it assessing your grade level concept that you're currently teaching, or are you trying to figure out what they're bringing in so you can use that for your next steps? When you're creating the task and probes, you want to make sure they're kind of open-ended, and you'll see why they need to be open-ended. We want our students to make the decisions. We want them to be able to explain the reasoning. So either they're explaining the reasoning verbally or in written form. I tend to use Post-it notes a lot, but you could use Padlet, you could use Peer Deck, you could use a Jamboard, whatever you're comfortable using to get students to make a decision and explain the reasoning. It also doesn't hurt kids to just sit and talk with a partner or share it out loud in class. The final two steps really is, we want to take the information, not just because we want to do it as a task, but we want to use that information as data. We want to examine and review the responses. That's why Post-it notes are really helpful, or Jamboards, because I can go back and look at that. And it helps me decide where are the misunderstandings, where are the understandings, and do I need to sort my students into some groups and really hone in on certain groups? Because I really need to know what's my next step for instruction. I don't want to keep going too far ahead when I have students who are at step 1 when they should be at step 3. So let's look at some examples into practice. So one of the tasks or probes is, which one doesn't belong? Danielson does a great job for the primary level in his little book about shapes. And then, of course, Mashup Math has a great collection for grades 1 through 8. I like it where there's only one correct answer. It helps with my test prep. It also helps with, kind of narrowing down like why something wouldn't work. But you can actually do it like our other two examples where there are many possible answers. And students don't really know what the question is, so they have to make sense. Like, what could the question be? You can have the students explain verbally to the whole class or to a partner, or they can put it in writing. You have to do it based on what your desired outcome is and what you'd use that information for, and your age level. So here's two examples. One's a primary example, one's an elementary example. Which one doesn't belong? Again, there's no other further information, so students get to start talking. If they're doing, if they're looking at it as, okay, let's look at it as adding one more. That's what I would look at this question to be, but maybe your kids see something different. Maybe your students say, there's numbers that are greater than 5. So you have to decide, your goal. If you want to give more prompts to it, you could. The second one obviously is about fractions and fractional pieces. It says which one doesn't belong. So again, you can leave it open-ended and see what your kids are bringing to the table. Some kids might say B doesn't belong because it's unequal pieces. That's great background knowledge for fractions. You already know that some of your students can determine that fraction is not equal pieces. It could be something completely different. It could be students are saying A, and maybe they're using that something's divided into fourths. And that can further your discussion. So whatever you want it to be, you can make it happen. This one is from the middle school level. Here I was definitely assessing, I did this right after a lesson on perfect squares. And we were looking at basically starting a lesson on square roots. So here, which one doesn't belong would be 8, or B, sorry, square root of 8. And again, I'm listening to what my students are noticing or what they're bringing to the table. They're noticing that weird check sign, which some kid will say, oh, that's a square root sign. They might notice that, there's numbers that look like they're bigger than 10 or whatever they want to say. So they might say some noticings, but then they're going to start getting into the meat of it, which is, oh, B, it doesn't belong because it's not a perfect square based on the information from yesterday. Now, if none of my kids said 8 and they were really stuck, then that means I need to go back a little bit and really revisit what is a perfect square, what does it represent, and how does it fit? Another probe that I like to use is who thinks like you. When I do the probe, I like to make sure that all of the methods that the students use to answer a question are valid. I don't like to put one that's not valid because, again, I'm asking who thinks like you. I actually have a caution for this one because if all the methods are valid, I will never use the question, who do you agree with? Because if all of them are correct, then they're agreeable answers. Like all the answers will be agreeable. They just may not do it that way. So that's why I shouldn't say agree or disagree because, again, all the answers are correct. So it might work for some kids, it might work for others. Let's look at one example. So I have this example from an assessment that I had done, and I had actually taken the students' work. And we had prices at a store, and then there was a 10% discount, and then they had to find the total price of 4.5 pounds at the discount. So Bella broke it up where she was using the information of per pound, and she knew she had to get up to 4.5 pounds. So she had to figure out, okay, what's going to be 4.5 pounds regular price. And then what was nice is she decided to use 90% or that 9/10 because she realized that, oh, if I'm going to the store, I'm not actually paying 10%. I'm actually going to pay 90%. I have students that do think that way. Maeve's method is using proportional reasoning, which is another strategy I had taught. So when she's looking at it, she's finding the 10%, which is the 16 cents, and then she's going to subtract that 16 cents because she knows the register is going to take away the 16 cents. And then she knows that it's also going to multiply 4.5 pounds. Henry's method is a little bit differently. He actually uses an equation, and he's writing that you take the total amount, you're going to take away the 10% of that amount to get the new discounted total. And then he's going to multiply by 4.5. So again, you're asking your kids which student thinks like them, not which one do they agree with, because all of them are correct. You might, on occasion, get a fourth response. You might have a kid say, none of those students agree with me. But that's why I always have a box at the bottom is explain your choice. Because if they have a different way that they would solve it, or if they have a combination of ways that they would solve it, they can prove it. So another one that's very similar to which student thinks like you is what's your strategy? So instead of receiving other student work to make sense of, they now are actually showing you what math they're going to apply in the strategy. I usually have more than one correct choice, and I usually start simple to more complex. So let's take a look at what this looks like. Again, it could be in written form or they can explain verbally. So this is a third grade example. So what's your strategy? Students were given this statement or question. David wants to sort 18 colored pencils equally into 3 art cups. How can this be done? They were given scrap paper, whiteboards, they could grab pencils from the classroom, they could draw, they could do whatever they want to show how David could figure this out. This gave a lot of good information. Got kids who could write equations out, you had kids drawing arrays and circling, you had kids, doing all sorts of different things to show what strategies they're applying. Then I took it the next step. And I asked the kids, could David sort the pencils equally into 4 art cups? I wanted to see if students could apply their strategy and go to the next step. Or if maybe they just kind of got lucky with that one strategy and it worked. And then I also asked about the 6 art cups, because sometimes I wanted to see if they remembered their fact families too. So there's a lot that you can uncover here and use, and you might be surprised by what you uncover. Here's one from middle school. Which expressions are true when x is equal to -1? You can see I do something a little bit more simplistic, a kind of a two-step problem with A, and then B is using the distributive property, and C is combining like terms, and D is adding fractions into the mix. So there are more than one correct answer, and I want the students to explain the choice. I give them lots of space to work out the problem, to demonstrate why it works, why it doesn't work. I'm again assessing what concepts of algebraic thinking are they bringing to the classroom. So Grace and Amy do a great job with these routines. So they are not just simple one-step probes or one-task probes. Yes. Amy and Grace do a great job with these routines. They're just not a one-slide type of prompt or probe. You explain the routine, and then there's a noticing piece with individual think time, partner think time, and then whole group share. Then you kind of revisit after the noticing and develop a shortcut to help you calculate. So using different strategies to calculate, and the students are bringing what they already know to the situation. Then there's where you're sharing out, and kids are basically explaining their strategies, and then they're reflecting, which is like an exit ticket. It can be very simple, like what are they going to remember next time they see this, or moving forward, what is important to notice. So here's kind of an example. This is only 2 of the slides. It's actually a little bit longer of a routine. Start off with what do you notice? Did this with kindergarten. We actually did a very simple prompt next, which is like start with what you notice. They started noticing 2 dots, 4 dots. They noticed square, they noticed circle, they noticed red, they noticed black. It's a very nice open-ended question because every student can say something, whether it's to your point or not. Then we change it to this. Find a counting shortcut. And we might say, I would like you to count the number of buttons. I would like you to count the number of holes in the buttons and how many total holes are there. So again, students are going to make some sense by chunking, changing, or connecting to math they already know. Here's one from middle school. This was before we had done multi-step algebraic expressions and equations. So I gave them this just to see what they were bringing to the classroom. They were already noticing parentheses. They were already noticing the variable. They were noticing addition, subtraction, fractions, decimals, whole numbers. And it was great because some of them were starting to use the 6th grade terms of variable, constant, coefficient. Then I changed the slide after we had some discussion and where the math is now attainable. And we say, okay, now it's your turn. Find the value of x. You might do that by chunking information together, changing the information, moving it around, using inverse operations, or connecting to something you've had experience to. The second routine I'm going to talk about, Grace and Amy have multiple different routines that I love, but these 2 are my most familiar. It's called connecting representations. I love it because students are making connections to the math they already know or what's been given. So explain the routine, think time, pair share, then you're studying the connections, doing a pair share and group discussion, taking notes. And then the twist to this one is one of the representations is going to be missing the second partner or the second piece. So you get individual time to think about that. Then you share with a partner what the connecting or the missing representation might look like, sharing out as whole group, and then discussing. And then the final part is reflecting. What are you going to remember next time? What am I taking away from this? So let's look at an example of this. So this was from a 4th grade class. We were looking at place value and multi-digits. We have 4 standard form multi-digit numbers. And then there's a representation about their place values on the right-hand side. If you notice, there's only 3 of them because A, B, C, or D is not going to be used. So the second half of the routine is, now that we've explained which ones connect to 1, 2, and 3, the one that's left out needs another representation. So what could that representation be? opens up a lot of thinking. And for your students who, may be struggling, they can use 1, 2, or 3 as an example for their fourth representation. A middle school example here was introducing surface area. So I had 3 representations of nets and solid figures, and I wanted them to start making connections between the parts of the surface area equation or formula to what they can see there. So I had a great conversation regarding the faces and the number of faces, the dimensions, and that was really kind of the meat and potatoes of my lesson is, can they focus on the details that they're given? So in summary, why we want to uncover student thinking with these math tasks, these probes, or these routines is because we want to engage our students. These activities really lend themselves to where students can bring in the math they already know, and they can talk about it. They can talk about it freely. They can talk about it with a partner. It makes it less like a test. I'm also doing it for my own purposes. I'm trying to assess what they know, because I don't want to be on step 3 when I really need to be still in step 1. So I'm using the probes to assess, to be my formative assessment. And like with the engagement, we want to make the learning accessible. When you have these variety of activities and probes and prompts and routines, the students are all able to contribute. They feel like they have some kind of empowerment or some type of engagement with the math, and they're more likely to want to persevere and make sense of the problems. And in addition to making sense of the problem, I'm trying to improve their mathematical thinking and reasonableness. Because if you notice, the strategies and the prompts are making them make a decision and explain their decision. Because we want them to not just accept things like, okay, well, so-and-so says the answer is 5, so it must be. We want them to be able to explain, why does that make sense? Why is the answer 5? How can you prove it? So hopefully these were just some general ideas of helping you get your students more engaged and helping you assess understanding. And hopefully you'll try some of these math probes and techniques and routines in your next lesson.